Hello again, and welcome back to Science 9. Today, we're continuing our talk about electricity, but in specific, we're going to talk about resistance today. We're going to talk about the concept of resistance. So what do we know so far? Well, we talked a lot about current, right? We talked a lot about current, and we even came up with this little triangle to help us solve for current, right? We had our total charge at the top, our current, and our time at the bottom. We also talked about voltage or potential difference. And again, we came up with this little triangle to help us solve for potential difference questions. In this case, we had our energy at the top, we had our voltage at the bottom, and we had our total charge at the bottom as well. This is nothing new. We talked about these in previous classes. What we're going to learn today, though, is we're going to talk about what resistance is. We're going to talk about what resistance is. We're going to talk a bit about the scientists that came up with the theory of resistance. And also, we're going to attempt to do some resistance-related questions. So let's get into it. Ohm's discovery. So Ohm was a German physicist, and in 1827, he experimented with various wires. So what his experiment involved is it involved the changing of voltage across various wires. In doing so, he was measuring the difference in currents. And what he found was that for most wires, the ratio between voltage to current is constant. And what he called this constant, well, he called it resistance. He called it resistance. So if we think about it practically, if we have a constant relationship between two different units, how does that look on a graph? How does that look on a graph? So if we had voltage at the top at our y-axis and current on our x-axis, how would a constant relationship look? Well, it would be a straight line, correct? It would be a linear relationship. So this is what he found was true for most wires. As I said, he called this constant resistance. So without knowing anything about physics, we can almost determine what resistance is, right? If we look at the English word makeup, we have resist. So we're going to think that something is being resisted. And that's correct. In our little cartoon diagram, what's happening here? Well, we have resistance. We have resistance resisting the flow of amps through our wire. Now, what is amps? Well, it's the unit of what? Of current, exactly. So all resistance is the hindrance of current through our wire. Okay, so the larger our resistance, the less current flow. Now, it's important to note that it doesn't stop the flow of current. It just makes it harder for current to flow, right? It decreases the rate at which current flows through our wire. The formula that we're going to use to calculate resistance or to apply resistance is simply R, or resistance, is equal to V over I, voltage over current. So if we wanted to draw another little triangle to help us remember, we would have our voltage at the top, our resistance, and our current at the bottom. Meaning if we were looking for current, it's simply voltage over resistance. If we were looking for voltage, it's simply resistance times our current, right? So this is another little triangle that we could add to our collection of little triangles in helping us solve for various electrical questions. So let's go through some unit analysis on resistance. I kind of like this little this little illustration, because it helps us in solving for our units. So who is this? Well, this is Ohm. This is Ohm. This is the physicist that came up with the concept of resistance. And on this side, we have Alessandro Volta. Alessandro Volta. And from his name, what do you think he came up with? Exactly, volts. Volts, or potential difference. And at the bottom here, we have Andre Marie Ampere. Again, from his name, what do you think he came up with? Well, he came up with amps, exactly, or current. So, if we just are looking at our units, what is the unit of resistance? Well, resistance, again, is volts over amps, which all equals ohms, Again, we're just looking at our units, right? And now, how do we depict ohms? Well, for voltage and amps, it's simply V and A, right? The units. But for ohms, it's the Greek letter omega. It's the Greek letter omega. So this symbol here depicts ohms, which is resistance. Right? So let's go into a few questions in relationship to resistance. Question 1. A technician is checking the circuits on a vehicle. The technician measures the current entering the component as 0.47 amps. The potential difference across the component is 12 volts. What is the resistance? So for, again, all science-related questions, we're going to use the guess or the grasp method to solve. So what is given? Well, we're given 0.47 amps, and we're given 12 volts. What is unknown? Well, our unknown is resistance. What is the equation we're going to use? Well, simply put, we're going to use resistance is equal to volts over current. We're going to go ahead and solve. So again, resistance equals volts over current. And we have 12 volts over 0.47 amps. So resistance is equal to 25.5 ohms. 25.5 ohms. And our statement, therefore, the resistance across the component is 25.5 ohms. And that's it. So these questions are very similar to the ones we were looking at in relation to current and potential difference. Now we're just looking at resistance. So if we remember our formula or our little triangle, we're able to solve these questions with ease. So I have one more that I want you to try on your own, and restart the video when you get either stuck or you get a final answer. So in this question, what is given to us? Well, an electric toy has a resistance of 120 ohms and requires a current of 0.05 amps to work. How many 1.5 volt cells does the toy require? So our given is 120 ohms, our resistance. And also we're given current of 0.05 amps. Our unknown, well, we're looking for how many 1.5 volt batteries are needed. The equation that we're going to use You guessed it, it is R is equal to V over I. And if we rearrange for voltage, because that's what we're going to need to determine how many 1.5 volts batteries are needed. So if we rearrange for voltage, we simply have voltage is equal to resistance times our current. So now let's go ahead and solve. Our voltage is equal to our resistance, which is 120 ohms, multiplied by our current. And our current is 0.05 amps. Doing this calculation, we get a voltage of 6 volts. That's great. That's not our final answer though. Our final answer, well, our question is asking how many 1.5 cells does the toy require? So if we need 6 volts and we're given 1.5 volts of batteries, it's simply 6 divided by 1.5, giving us an answer of 4 batteries. So our statement at the end, therefore, we need 4 batteries to power the toy. And that's it. So these questions are very similar, like I said, to our current questions as well as our voltage questions. All we have now is a different formula, but the process remains the same.